Okay, good morning. I'm going to go over some of these motion graphs. I'm going to go over the first couple in each section, and that way you can hopefully see how it goes and complete them on your own. So the biggest thing, again, the big idea with a distance versus time graph, note up here it says x-axis is time. So all of these really have a time on this axis, and it's a distance, or we've been saying change in position for my y-axis for all of these. Now notice down here, now it's velocity versus time. So I have a velocity versus time graph, which is different than a distance versus time graph. And we're going to see how. So on a distance versus time graph, the big idea that you guys have written down many, many times is that the slope of a position versus time graph is velocity. I'll write that out. So the slope of a position or distance versus time graph is velocity. Okay? It's how fast you're going, because my units would be something like meters per second, and I know that's a speed. So this graph, this first graph right here, this is a position versus time graph, and so my slope is going to be the velocity. Slope is rise over run. So the rise that's happening is 1, 2, 3, 4, 5, 6, 7, and it happens over 1, 2, 3, 4, 5, 6, 7 seconds. So rise over run is equal to my slope. Well, my rise is 7 meters. My run is 7 seconds. Therefore, this slope right here, and it's constant the whole time, is at 1 meter per second. Now I can translate that to my velocity versus time graph by starting at finding the 1 meters per second and drawing a line across. Okay? Let's try for the second one. So now, look at this one. So this slope right here seems much steeper than the other one. So I'm guessing, since it's a steeper slope, that means the object's moving faster, whatever the object is. So now I've got a rise of 6 over a run of 2. Okay, well, 6 divided by 2 is equal to 3 meters per second. But it's only going 3 meters per second for the first 2 seconds. So down here on my velocity versus time graph, I'm going to find the 3 meters per second, and I'm going to go 2 seconds. There. Then the object stays at position 6. There is no slope. Therefore, its velocity is 0. And I can make it like that. Okay? So that's how this first level 1 of these graphs go. Let's take a look at level 2. So level 2, it looks like I have a starting position here. Oh, but it's telling me my velocity down here on my velocity versus time graph. So the velocity versus time graph here is -1, and it's -1 the entire time. Well, I know that a slope of a distance versus time graph, distance versus time, is going to be the velocity. Well, if velocity is -1 the whole time, that means I need a slope of -1 the entire time. So the slope of a -1 has to mean, we're not going to go backwards in time, so a slope of -1 would have to be a negative distance over a positive time. And so that means I'm going to be going back 1 meter every second all the way to 7 seconds. Okay. Now, if I was to check this slope, I can see my rise over run. Rise over run is my slope. Well, the rise is actually a -7. My run is a 7. That's going to give me a -1 meters per second. Okay, let's try the second one. Let's see, it starts out with a velocity of 0 for 2 seconds. So that means I'm in the same place. Even though I started at 1, I'm in the same place. I didn't go anywhere for 2 seconds. Okay? Then I shot up to a velocity of 3 meters per second, and it's positive. Well, 3 meters per second is my slope. So I need to go up 3, 1, 2, 3, and over 1. And that's what happens in 1 second. I'm at 3 meters per second. The second second, it happens again. I'm still going 3 meters per second. 1, 2, 3, 1 here. So this is what my velocity would look like here. And if I was to check that slope of that, I would see that it's 3 divided by 1, which is equal to 3 meters per second, or it's actually 6 over 2, which is also equal to 3 meters per second. So I'm checking my slope right here to see that, yes, indeed, it lines up with this 3 meters per second here, right? 3 meters per second is my velocity. And then what happens at the end? Well, looks like I'm not moving from that spot because my velocity is 0. So it looks like that. Okay, so that's how we do level 2. Now, the hard one, level 3. Now the key here is all of these have curves in there, which we can't find the slope of. But I can find the slope of this one, and then connect the curve with a straight line. So what I'm going to do is on my distance versus time graph, I see I'm here at 1 and I'm staying at 1, so that means my velocity is 0 for the first 3 seconds. Okay? Now it does some weird kind of curve. Well, I don't know what the slope is there, but I do know the slope from here to here. It looks like it is, let's see, 1, 2, 3, 4, 5. 1, 2, 3, sorry, 4. Goes up 4, 1, 2, 3, 4, and over 2. So my rise over run, 4 over 2 is equal to 2 meters per second. So that means for seconds 5 through 7, I'm going 2 meters per second. So 5 through 7, I'm going 2 meters per second. So I put a line there. And now I just connect these with a straight line. And it looks like that. So I started out going a 0 meters per second for the first 3 seconds. Then I accelerated. Look, my velocity is changing. It's accelerating. And then it is flat again because I'm going 2 meters per second, but not changing. The slope is constant. And here it is a slope of 2. Or sorry, 0 slope, but a speed of 2 meters per second. All right, let's try this second one right here. Again, I've got a flat part here and a flat part here. I'm going to try and find the slopes of that and then connect this two with a straight line. So my first slope, it looks like I'm rise of 2, run of 2. Okay, so this first part here is 2 divided by 2, which is equal to 1 meters per second. 1 meter per second. So for the first 2 seconds, I'm going 1 meter per second. Then I have this weird curve thing going on here, which I'm not even going to touch. I'm just going to go to this last one here. And this last one looks like I'm going a -1 over a 1, which is equal to a -1 meters per second. And I mean -1 because I'm going down, right? I'm getting closer to the position, the 0 position. So now I've got -1 for the last, only the last second. I'm at -1 meters per second. And then because I have that weird curve there, I connect it with a straight line. And there is my graph for that one. So notice here, as it's curving, what's actually happening? Well, this would be like I'm going away from the position, I'm going away from the position, I'm slowing down, stopping, going back towards the position, Let me do that with a better highlighter. Oh, you know what? I have a pointer. Where's my pointer? My highlighter pointer. Where are you? I think, is it this one? Okay. So look, I'm going straight. Then I'm slowing down, stopping here at the top, and now I'm going back to the start again. So we can see that again down here, where I'm moving away from the center at a velocity of 1. Then I'm slowing down. I'm stopping where the velocity is 0, and then I'm speeding back up, but back towards the start again. Okay? Well, hopefully that was helpful, and I look forward to seeing your learning.